This is John Black, super chemist. So as you can see over here, right? The wave, this is the wave function, right? The higher it is, right, the more probability you have to land on this spot. Like right here in the middle, you can see it's the highest peak. That's the highest probability you will land right here. Now, what they're saying, these crazy woke physicists, right? They're saying no. They're saying because we can't measure it, okay, until it gets here, because it's not a particle. The electron is smeared out, okay? You know, let's say the probability that you land on this spot is, 30% or whatever, right? They're saying that the wave function, all these percentages, right? That's the percentage that, the electron is smeared out all over the place, right? And it's not the probability that it will land on one of these spots. No. That's, the electron is spread out like 30% here, 10% over here, 50% over here, 30% here, 40% here. It's smeared out. That's what they're saying the probability wave represents, is this smeared out electron, okay? This stretched out electron. Yeah, the electron looks fuzzy because it's freaking small and it's vibrating, you idiot. But see, they think they can't measure it, right? And they can't get the momentum, position, and all this other stuff right, because it's so small in that. And instead of just saying, hey, it's small and it vibrates like this, you know what I mean? So I can never know its momentum or position exactly, you know what I mean? No. They have to say, they think they're God, okay? They're like, I'm God, man. It's not that we can't measure something. No, God can measure anything. It's just there's nothing to measure because it's not really a particle. It's a smeared out wave function. And until I measure it, or until it hits, the wall or whatever, right? It's just a wave function, okay? It doesn't really exist other than as a smeared out probability wave, right? And when you look at it, or you let it, you detect it by it hits the detector, meaning the wall, you collapse the wave function down into a specific position. That's what they believe. They think they're God. Like, if I can't see it and measure it, then it doesn't exist. Obviously, it's a wave. It's a wave function. It's just smeared all out. 30% of the electrons over here, 10% over here, And when we look at it, it'll all collapse all down into one little point. Because I'm God, and obviously, if I can't see it or measure it, obviously, since I'm God, it obviously doesn't exist. Okay, it's not that I am inadequate and I can't do these measurements of this electron's position and momentum and all that stuff. No. I'm God, so obviously it's a wave function. It doesn't exist other than a wave function, and as a wave function you can't measure those things because they don't exist. Those things don't, when you're a wave function, you don't have position to measure. So it's not that the woke physicist, it's not that I'm inadequate and can't do it. No. It's it doesn't exist. That's why, and if you don't believe me, okay, I'm going to show you a clip. It is literally like at this spot right here on the screen, he's already there. The electron is there already. Same here. The electron is all over here. Okay? This wave function here, that represents the percentage that the electron is there. Not the percentage probability that he might be there. No. Before you shot the electron, okay, he was not an electron. He was a wave function all spread out of here, okay? And it's just in this band of thingy here, this is how much, like let's say this was 60% and then 20 and 10, okay? All right? So, yeah, this line right here, right? 60% of the electron was there. And see here? 30% of the electron was there, or 20%. And then 10 was here, all the way up here. Same over here, 10%. And the electron was smeared all over here, okay? Okay, because I'm God, right?
And so if I can't, obviously I'm God, so I know everything, right? So if I can't see the electron, it can't be that I can't see it because he moves around and it's too small. It can't be that, okay? Obviously, because I'm God, right? It has to be the electron is the electron doesn't exist at that point, because I can't. If I can't see it, if I can't, if I can't know everything about it, I'm God, and so it doesn't exist, and therefore it is a wave function that's spread out all over here. These are probabilities, percentage probabilities of where the electron is, okay? Not where it might be in the future. No. Because I'm God. All physicists are God. So obviously, they don't. There is no electron, okay? There's only the wave function. It's only a spread out thing of the electron. The electron's all over here. Okay, it's not that I don't know. I know I'm God. Of course, the only way I can stay being a god, right, is to give you this fantasy story, okay? Right? When the customers go into the thing, they exist before they come in, okay? They're not a wave function, and when they come in and spend money, the wave function collapses, and now they exist. They're people. They exist, okay? Just like the electron exists. Just because you can't see them and you can't measure things about them, that just means you're inadequate, okay? Doesn't mean that the electron, you're God, and the electron is really just smeared all out of here. This just tells you, it's 50% here, 20% here, it's 10% over here. No. You just can't see. Why can't you just admit it? Just like these customers. I don't ever leave my house. I've never seen these customers or gamblers. When I see this graph, what does that mean? Since I can't prove the customers and gamblers are there, since I can't prove it and I can't see it, should I just assume I'm God and say, oh, those people don't exist until they spend money, and then I get the report from my company telling me this stuff? Till then, I'm God. These people don't exist. They're just like in a wave function, spread out all over the entire universe until they walk in and spend money at my establishment, gamble at my establishment, because I'm God, right? That's the way that all makes sense, right? So when you hear these people saying, "Oh, the electron isn't," it's smeared out because the wave function. This is the wave function. They're talking about a bar graph, okay? Because this and this are the same goddamn thing. This is in bars and this is in waves. It's the same fucking graph. They're literally saying the electron is a bar graph smeared all over the place because they can't measure stuff, because they can't just say, hey, it's really tiny, it oscillates, when it moves, it oscillates. I can never really pin down his momentum or his position because of that. Because if I hit him with a photon here, I know he's there. Yeah, sure. But where is he on it? He could be up here, so his momentum is going that way. He could be down here, where his momentum's going up. He could be here, where his momentum's going down. So we don't know where he's at after that, because we don't know how he hit him. We don't know where he was on the sine wave, where he was in his oscillation when we hit him at this point right here. Instead of just saying that, you have to make up all these stories. Like I said, we already proved scattering, diffraction, all this crap, man. Interference, it's a mathematical thing. All it means is that you're oscillating. Doesn't mean that you're a wave, because if you're a solid oscillating and you're a wave, right, you use the same equations because you get the same probabilities. Yeah. Look over here, this pendulum right here, right? The wave function, right? The wave function, right? And wave equations explain this pendulum better, more. This has proved more than quantum crap, right? Right? Does that mean this is a wave? This isn't a solid here, pendulum? Pendulums are no longer solids. Is that what I'm supposed to believe? Because if the wave function explains this better than this, a lot better than this, so this should be even more of a wave than these. Yeah. So the wave function, all it does is tell you the percentage that you can land here, or whatever it is, or a customer come into your whatever, or that you get a high number or a low number. It's just a probability thing. Like you go to the not Las Vegas, and you'd have these probability things, for gambling. Does that mean those probability that all probabilities are waves, huh? These people and customers are waves, huh? These numbers are waves. These electrons are waves. They're talking about a bar graph. This is the wave function. They're saying this information, this here, spread out. My bar graph has been spread out. That's what the gamblers, when they go into the CEO thing and they're talking about the people that came in and gambled and stuff, and they show this chart and that. They don't exist until they come in, until they spend the money. Yeah, because they're conceited too. They're evil too. Anyone who thinks that things only happen when they look at them, yeah. Those people are nut jobs. Okay, they think they're God. Okay, they think that things don't happen unless they're there to see it. A tree doesn't make a noise after it falls unless they're there to hear it. You know what I mean? The electron doesn't exist if they don't have the ability to measure it, properly and do the momentum properly. If they can't. Well, it's not because they can't. It's because God can do anything. God knows everything. It's just that the electron doesn't exist during that time where they can't, where they're doing measurements. The electron doesn't exist. It's a probability wave. Them saying probability wave and admitting it's a probability wave, meaning it just represents probability, would tell everyone that it's just a mathematical, construct.
You can see over here, right? The wave, this is the wave function, right? The higher it is, right, the more probability you have to land on this spot. Like right here in the middle, you can see it's the highest peak. That's the highest probability you will land right here.
But quantum mechanics says that this is all wrong. A particle usually doesn't have just one position or one momentum or one energy. Instead, it's in a quantum superposition of different options. But that's not the only thing wrong with giving just a list of numbers to describe the state of this electron. In quantum mechanics, the information about the position is not independent of the momentum and energy. Instead, all of the information about the state is packaged together in something called the wave function, and it's represented by this thing here called psi.
Before we go into her, clip, I wanted to say about the wave function. That it's not the wave function is actually several wave equations or things. You know what I mean? Derivatives, maybe you might call them. It's not just about one. Like I was basically going into a position thing, but if you get the derivatives, you got your position, you got your velocity, you got your acceleration. Depending on what your wave function is describing, you know what I mean? We were talking mainly about the two-slit experiment, and so we were obviously talking about position, the position that the electron would hit the wall or the detector. But the wave function is basically a superposition of all the mini, mini waves that represent that same particle, you know what I mean? Then you get all the, the position, the this, the that, the momentum, and they all have a wave, associated with them. Then you take all those waves and you get the superposition of that. That's the actual wave function, okay? But when we were talking about position, we were talking about position. Okay, this is Looking Glass Universe. What is the wave function?
Quantum mechanics works. So let's try and understand the wave function. We'll start by trying to write the wave function in the so-called position basis. As you may know, in quantum mechanics, no object is allowed to be in exactly one position.
Yeah, because it's vibrating. It doesn't just sit there, it vibrates up and down. Instead of them just admitting that, they're going to make up these stories.
There's always some amount of fuzziness to where it is.
Yeah, because it's really tiny and it's vibrating, you moron.
In fact, it makes pretty little sense to draw an electron like a little ball like this It's